is a 2.7 volt type of supercap, and not so uncommon. And yeah, use the internet to download the data sheets. And you can order components, not in really large volumes at this point. So looking a bit into the inside of these products, it's a sustainable material recipe, fundamentally the sort of the best BOM that we think you can get to. And it's the production technology itself that is unique. So that combination is what makes this sort of alive. The company, just a few words on that. We're as I mentioned, we're Sweden-based, and we're founded as a spin-out from materials research. So in the beginning, for 3 years, we worked with larger type of sort of more energy components for in the beginning, actually grid components. So we made cells, built them, but we realized at some point that, okay, it's better for us to make smaller objects and mass produce them, still utilizing the way of building the components and the material science. So 3 years ago, we decided to focus on that. It's a roll-to-roll based production technology fundamentally, and I'm going to show you a few steps in the process later on. And you see some machinery there, and we're going to have a presentation after me, I think, on machineries, so it connects to that. But in this case, it's actually, for the ones of you that knows this, it's a Delta Modtech on the picture here, and it's a Krönet coating line. So that's the two key machines for us. The way to build a cell now, this is I would say to some extent it's no rocket science when you look at the steps on this level. It's a slurry-based, coating-based way of building the cells. Includes a third step is the calendering, basically pressing the electrodes, and then you move into the conversion phase of making the cell, so that singulation, stacking the objects in a smart way, assembling the cell to an open solution, and at some point in the end you actually fill and seal the object. And loads of testing and packaging in the end if it's a mass production facility. So this is fundamentally, I would say, on this level not super unique, but in the details it's unique. A bit back to the sustainability side of this. It's a very conscious selection of materials in the BOM, and we have looked through all the elements and consciously selected a combination that makes it what we see as the most sort of sustainable you can get. So it's of course no lithium, no perchlorinated polyethylene. So we avoid the substances that we believe is loaded from an environmental point of view. The form factor then, if we compare a component like this, it's actually the smallest component is below 0.4 millimeters, and that's what is sort of required to be inside a credit card. And it's, if you compare it with a traditional supercap, which in many cases could be the most sort of relevant option, we cannot beat that component in price. This is a $1, €1 component, but we can beat it then in the thinner side and in the sustainability side. So if we're into thinner and thinner objects, the traditional supercaps, they are too big, even if it's a small version of them. So responsible materials, we have actually done an LCA analysis of the component, ending up with 6 grams CO2 per object for this size that I have in my hand. And we call call it that we have a practical approach to the disposal of